All right. Good morning, everyone. My name is Sean Davenport Smith, and thank you for joining us today's long coffee break. Today we have Scott Blackman. He's the National Sales Manager with RM Manifold, and we'll be discussing some mechanical draft solutions. With that, I'll turn it over to Scott.
Thank you, Sean. As Sean said, my name's Scott Blackman. I'm the National Sales Manager for RM Manifold Group. RM Manifold Group goes to market under several different brands. US Draftco, which handles hydronic systems, which we're going to talk about today. LF Systems, which does kind of the air side components, laundry rooms, stairwell pressurization, laundry, multifamily type situations. And then KW USA is a kind of a joint venture that does pizza ovens and fireplace fans. When we talk about natural venting, a couple things to keep in mind for natural venting. Basically, natural venting is anything that is a individually vented appliance up to about 25 feet. Now, I highly recommend this way of venting appliances. It's the way they're tested in the factories. It's kind of the way they get their labels. It's the easiest, most headache-free way to do venting for an appliance. Now, I don't get to sell a thing on it, but it's just a headache-free, easy way. Now, there's a couple things to keep in mind when we're doing natural venting appliance. Appliance category does matter. So we want to definitely pay attention to whether it's a Cat 1 or a Cat 3 or 4. PVC, CPVC are not listed venting materials, and we obviously want to follow the appliance manufacturer's installation instructions when we're doing that. So why do I get called? So one of the reasons I get called is for violating venting codes. One of those venting codes that's commonly violated is the 10-2 rule, and that's basically you've got to be 2 foot above anything within 10 feet. That includes walls, roof peaks, parapets, equipment hides, anything of that nature. I like to show some of these pictures here. Basically, this first one, you're not going to get a lot of draft off of that appliance. You know, it's basically hugged right to the roof. You don't have any kind of stack above the roof, allowing for to create some natural draft. That third picture right there, they did great. They got over the parapet wall. Congratulations. They just kind of forgot about the penthouse wall right beside it. And then that last picture is my favorite. I call it the sleepy time picture. That's actually a fresh air intake that the boiler flue is butted right up against. So definitely should have taken a look at that, and raised that another, 5-6 feet to get it above the fresh air intake for sure. Another common code violation is the 7 times rule. So anything, you can't vent anything 7 times larger than the smallest outlet of the appliance. So I can't take a bunch of, 4-inch outlet water heaters and dump them into an existing 36-inch chimney. Basically, it's the same principle as trying to prime your chimney at home with a Bic lighter. You're just not going to create enough heat to create enough natural draft to draw those products of combustion out of that chimney. Another common code violation is mixing categories. So like I'd said at the very beginning, you want to pay attention to categories. Well, you can't mix category 1 and category 4 or category 1 and category 3 without doing some kind of mechanical draft system. Another reason I get called is basically just common venting itself. There can be some things that need to be looked at and kept an eye on, and also exceeding the manufacturer's recommendations. When we're talking about common vented boilers, it's just a simple, sketch of 4 boilers, all put on one single common, going out a single penetration. Very, very commonly done. But there's some few things that you need to take in mind when doing common venting. One of these good practices is the static regain method is great for HVAC distribution, but it's absolutely horrible when we're talking about doing a common vented boiler system. We want that common to be one single size across the entire common, because every time you change sizes on the common, you change the pressure profile. So it's hard to get a true picture reading from start to finish if they're changing sizes and changing that pressure profile. Another good practice is boot tees and lateral tees are your friends. Straight tees are not. Air is stupid. It will do exactly what you tell it to do. So if you tell air to run straight into a wall, it will do it. And that's what happens with a straight tee. Air runs straight up into the top of the tee and can create basically an air dam that can create a blockage for boilers that are behind it. So we definitely want a lateral tee or a boot tee. We want that air moving in the direction of the exit instead of just deadheading at the top. When we look at a common vented system, we can get a wide range of pressure inside that common. One of the biggest reasons for that is when we size a common stack, we size it for all of the boilers connected to that common at full fire. So we've got to get by code, all of the products of combustion out of that system. Well, that can create a pretty wide pressure range when we're looking at, a shoulder month and we're only running one boiler at, half fire or even full fire. We've got a wide range that can range anywhere from, a deep negative to a positive. We can cross that zero barrier. One of the reasons for this is we kind of see this in the actual what goes on inside the common when we've got multiple boilers firing. When we get the first boiler call for fire, it goes into a pre-purge. It dumps cold air into that flue, cools it down, starts to light, ramps up. That second boiler calls for fire, pre-purge, cools it down. So we get this roller coaster effect, as you can see, until we actually get to a place where we're at a steady fire rate and a steady flow rate. And then the converse happens when you start to have boilers turn off. So basically, I get called when we don't have enough draft. When we have sized a common for full fire, but we've only got one boiler running or we've got two boilers running, and we need to be able to reach that full fire. I do that with a series of fans and controls. I've got all different types of fans, termination fans, inline fans, 90-degree fans. Our fans can handle for temperatures up to 1,000 degrees. We've got models capable up to 16,000 CFM. They're UL listed for 705 and 378 for indoor-outdoor installation. The nice feature about our fans is they're all stainless steel. So they're either 430 or 316, depending on the application. And that includes the housings, the impellers, every part of the fan that would come in contact with condensate or products of combustion. This is just kind of a simple sketch of a system where you have a pressure probe there. Like I said earlier, you want that common at a single size. You've got a pressure probe at the end of that common. You've got either a fan inline or on top with a controller, and we're basically controlling the pressure inside that common. Well, what happens on if we've got 4 or 5 boilers on a common, we've sized it for max load, we've got a large fan controlling that common, but all of a sudden it's a shoulder month and we've got one boiler running at maybe half fire or quarter fire. Well, we might have a case where we've got too much draft because most of fans can really only turn down about an 8-to-1, 10-to-1 turn down. So what we do is we add a overdraft damper to that system. We add a stainless steel damper. It's got a 2-second actuator, and basically we create false back pressure in the system. So we kind of create a false, we allow that kind of, it basically narrows down the flue to allow that single boiler to run at a quarter fire or a half fire as needed. Simple sketch of what that would be. It'd be that same system, but we'd have that damper after the last boiler before the fan. And like I said, it just turns down, kind of closes down a little bit when needed to create that false back pressure to allow systems to operate properly. Mechanical draft control. So that's really what US Draft started as, is a draft control company. I like to say that we're a control company that also builds fans. And the reason for this is we developed what we call EC flow technology. And what that is existing control technology out there is basically single direction. It can read about a negative 0.06, a negative 0.6 to about 0, or 0 to 0.6. It's set at the factory. And basically that allows you to see one side of the coin, if you would. That works great until you get a situation where you get a boiler where, you've got that first boiler going, that second boiler goes into pre-purge, dumps cold air into the flue, and all of a sudden that flue goes a little bit positive. Well, with existing technology, that system doesn't know exactly how far it's gone positive. It just knows it's gone positive. So it ramps the fan up and starts a hunting and seeking process until it can reach back down into set point. Well, the problem is if a boiler goes to fire after pre-purge and it's still in a positive, it can go off on a block flue switch and we can have that boiler shut down, go to the next boiler. We can start to get short cycling in the systems. With EC flow technology, we can see across 0 1 inch. So we can see exactly where that pressure spike occurs, ramp the fan up accordingly, meet it, bring it back down into set point, and we can do that about 40% quicker than the competition can. All of our controls, from our little control down there in the corner all the way up to the big controller with the touchscreen, have this EC flow technology in them. They all have bidirectional pressure transducers that allows us to do high and low pressure safety functions. Most of our controls are integrated with a LCD touchscreen. And all of our controls are Modbus communication standard. Yes, we can do BACnet through a Babel Buster or Gateway. This is kind of a look at our touchscreen controls. Our touchscreen controls are another thing that really set us apart in the industry. We can basically, as we're making changes, because our controls are fully field programmable, as we're making changes, we can actually see that in real time. So there's no punching buttons, backing back out, waiting for the system to reset and start. As I'm changing the fan level or the pressure settings, I can actually see in real time what's going on. Another nice feature about our controls is all of our controls can handle multiple operations. So I can handle an exhaust and a supply air side. I can handle that overdraft damper we talked about. I can handle all of that all on one controller. So I don't have to have multiple controllers trying to talk to one another, trying to communicate and get things balanced out. So everything I've talked about so far is kind of a macro approach to controlling boilers in a common vented system. It's the overarching, we're controlling that main common, we're controlling the pressure throughout the system. Well, when we look at individual appliances, what does the individual appliance care about? It doesn't really care about what's going on in the common. It doesn't care about what's, going on in the, way down with the other appliance. All it really cares about is what is going on at my outlet. That's where it reads its pressure. Can I light? Can I protect this flame? Can I continue the way I need to continue? Well, about 8-9 years ago, we released the CDS. And the CDS is a modulating damper that goes on the outlet of the boiler and basically, or appliance. And it basically maintains that appliance at whatever set point that appliance wants. So this allows me to do a lot of things that I couldn't do before. One of the things that I can do now is if I've got a common vented system, I can now size my common for a slight negative, whether I do that naturally or I do that with a fan system, and set each one of those appliances with a CDS and set it to the draft that that appliance wants. So what that allows is it allows that technician to know that, hey, when I go in and commission these systems, I now have perfect guaranteed draft no matter where I'm at in, whether I'm commissioning this in the middle of July or I'm commissioning this in the middle of December. I now have perfect draft. I know that I can turn and tune this appliance to whatever it needs because my draft is always going to be the same. Another thing it allows me to do is allows me to mix things. I can now put a couple of boilers and a couple of water heaters all in the same common. I can size that common for a slight negative, put a CDS on each one of those appliances, and set it for each individual set point. Like I said, it's a stainless steel damper. It has a 2-second actuator. Basically has a Viton gasket, makes a positive on-off seal when it's off, and basically sits there and modulates. Again, Modbus communication. It's very simple to connect. This system basically requires either 120 volt from an outside source or 24 volt from the boiler. And it takes an alarm wire and a demand wire. So this is also a really good product for if you've got even a single boiler that maybe has a 50-foot stack and it's been giving you problems because it won't, that keeps pulling the flame off in the winter or won't be able to control its, go down to a low fire setting, in a shoulder month. You can add a CDS to that system very, very quickly and easily without having to add all these extra controls, and it will control that system the way it needs to be run. Last thing I'd like to talk about is boiler room safety. If I was the king of the world, I would require a CO monitor of some type, whether it was mine or somebody else's, in every mechanical space. Basically, you want an alarm that can handle both, has an audible visible alarm, can handle, being either wired into the control panel or wired into the gas safety punch switch. And basically, when it reads a unsafe level of CO, it would cut itself off. And last but not least, basically we do all kinds of sizings and calculations. So I've got a full engineering team on staff that does these day in, day out. So if you guys have a project that you're thinking, hey, maybe we need to take a look at this, maybe we need some calculations run, we do these for free. We're more than happy to help. Just reach out to your long salesman and we'll take care of it. And with that, that's all I've got.